The city of Portland has been dealing with sewage for a long time. Back in the 1900s, most of it soaked into the ground through cesspools and backyards. When it rained, these drains would overflow, leading to outbreaks of cholera and dysentery. To address this problem, the city began construction on what was then the largest and most expensive sewer project ever attempted. What we now call the Taggart Outfall is a 10-foot wide brick sewer line running 3 miles from southeast 82nd Avenue to the Willamette River. At its deepest point, the sewer is 100 feet underground. During heavy rains, it sends 18 school buses worth of sewage and stormwater each minute to the treatment plant. This helps prevent combined sewer overflows to the river. Taggart serves a roughly 5 square mile area of southeast Portland that includes 18,000 homes and 1,700 commercial buildings. It was dug by hand with picks, shovels, horses, and some dynamite. Rain would flood the trench regularly, and during construction, 6 workers were killed, including 5 who were crushed in tunnel collapses. At the time, the Oregonian would describe this as a fair safety record. Like everything else, tunnels age, and at 114 years, this one is nearing the end of its functional life. A collapse could flood almost half of southeast Portland, so it's time for rehabilitation. Built on what was once undeveloped land, today Taggart runs beneath homes, commercial buildings, a major highway, and several active train lines, so digging an open trench to replace the pipe was completely out of the question. Typically, brick sewers are repaired by bolting together corrugated metal liner plates and injecting concrete to hold everything together. Unfortunately, this greatly reduces the diameter of the pipe and requires many hours of labor. Instead, engineers at the Bureau of Environmental Services decided to try something more innovative. Using 3D scans of the existing tunnel, they designed a series of custom fiberglass pipe sections that could be installed and grouted in place. Since the composite walls are thinner and the interior is smooth, the flow reduction is minimal. While fiberglass is more expensive than steel plates, the overall capacity of Taggart is maintained, and the cost to install is far lower than with metal liner plates. On this project, there were 3 main obstacles to overcome. First, they needed to dig a large access shaft in a densely populated area. Fortunately, the city was able to rent an empty lot and create a plan to mitigate noise. With that done, the main shaft was dug, concrete was poured to protect the opening, and a large crane was erected. On to the next problem, how to keep workers safe. Today, we would consider the death of 6 workers on a city construction project a staggering tragedy of national proportion. So prior to any underground work, ground-penetrating radar surveys were used to detect weaknesses around the tunnel. Unsafe air is one of the biggest dangers working underground, so soundproof ventilation fans and regular air testing protocols were set up. Another major risk was flooding. Since rain can completely fill the tunnel in just 45 minutes, underground work was scheduled to be completed in a single dry season, meaning some areas would be under construction 24/7. The final obstacle was a tight squeeze, literally. Engineers needed to be certain that the pipe sections they had designed would actually fit through the tunnel. 3D scans of the existing sewer showed that it should work, at least in CAD. But before fully committing to purchasing $3 million worth of custom fiberglass pipe, they decided to conduct a physical test. Carpenters constructed a scale model of a pipe section out of wood, disassembled it, and brought it down into the tunnel. After putting it back together, they used winches and pulleys to physically drag it through the sewer. At each bend, they measured how much clearance there was around the wooden ring. Every lump of mortar on the bricks, every jutting pipe connection. By the end of the test, they had their answer. It fit, just barely. In some areas, it was less than an inch of clearance, but the test was considered a success. Isn't it amazing that a tunnel like this was built so accurately in 1906? And so the project continued. 363 sections of pipe were custom made and shipped on a barge through the Panama Canal to Portland. At the same time, narrow tracks and an electric train car were installed in the tunnel floor. When the pipe sections arrived, they were lowered one at a time into the tunnel, then pushed by the train into position. A custom-made pneumatic frame called the flusher was used to align them, and then jacks were used to seat each section in place. Every 100 feet, hydraulic concrete grout was injected around the pipe and inspected to make sure there weren't any gaps and that the pressure was up to spec. Work is scheduled to be completed by the fall, and once done, the Taggart Outfall should be in service for at least another 100 years. Projects like these are what keep the Willamette River clean and safe to swim in. They contribute to habitat restoration and make Portland a better place for people, fish, and animals alike.